Well, hello everybody and welcome back to Schoolwork Apps. If you don't know who we are, then we are Schoolwork Apps where we help you to solve hard sums and study good. So today we are continuing the series of periodic table. Let us start this part 4. Stay tuned. We will study matter today. See matter. Whoa, it came. Matter. Let's go deep. So in this part we will go into nature completely deeply. We'll see everything. Let us see what we have got first. To this slide I will come you later. Let me first see timeline. Okay, so what we have studied, this is the timeline. So basically you studied the first part about physical states of matter. In the second part you saw about the pure substances. In the third part you saw about impure substances, and the final part there now we will see many things. Let us see what we have got next. What we will do, as I said, we will see many things. We will see introduction, we will see matter, what is matter by the way, we will see isotopes, atomicity, we will see process and activity, we will do chemical formulas, and then summary at the end. So let us start. Let me go back to that slide which I see. Now you all have seen this thing, right? Whoa, now it's familiar to me. Just see. Let me mark it for you guys. Let me do it, okay? So when we change a liquid state into solid, we say it freezing. When we do solid to liquid, we say it melting. When we do liquid to gas, we say it boiling or vaporization. And when we do gas to liquid, it is said condensation. Okay, so now next, when we do directly solid to gas, we call it sublimation, and deposition is when gas go directly to solid. So you all have seen these things. I know that you've seen it. So you need to just revise them. So I have done an activity for you guys. Just see it. We will be in the activity soon. Let us count 1, 2, slide. Okay, so atomicity, the first topic today. Atomicity. What is atomicity? What is an atom first? Atom may be considered as the smallest fundamental unit. Is it? No! By Dalton's theory, it is proposed that the matter is the most fundamental and the smallest unit. But no, after that, many new things came such as neutron, electron and proton, which are smallest of a matter. Okay. So, now we have protons, electrons, neutrons as the smallest unit. Okay. Now let us see what we have got next. A matter has many molecules. Also, molecules have a number of atoms. And thus, according to the number of atoms present in a molecule, we name it different names. We give it different names, and those names are called atomicity. So now let us talk about the labels there. The labels are monoatomic. What do you mean by that? The molecule contains only one atom. Remember that, only one atom. Next is diatomic, where the molecule contains only two atoms. Then polyatomic, where the matter contains more than two atoms. Okay. So let us see next. Here is a small triangular type structure which will help you recognize it. So first on the top we have monoatomic element, then we have got diatomic element. Whoa! With the transition. So symbols. How do you represent an element? There should be something. Yes, you're at the correct place. These are symbols which will help you to represent an element. So first we have got to represent different elements and compounds. We use different symbols. Remember that these symbols were started by Sir Dalton, who was a scientist years ago. Sorry, just a joke. Years ago, he was a scientist. He made symbols such as this. Like that, he made many different symbols, and then that method got popular. Everywhere it got popular. But there were some issues too. If you invent something, there will be some issues too. So the issues were they were not proper. They were hard to be recognized, and thus they were not a proper method. And thus Sir J.J. Berzelius, who also was a scientist, soon after the discovery of symbols, came after good method. What is that method? He had all symbols for all elements. Okay. They started with the name of these elements. This method was much recognized and well known. Nowadays we use that method only. So J.J. Berzelius did it. So now let us see what is that method. Some rules we will see. Okay. So if you don't know, like this was the place where Dalton's method was famous, but now it's not used anywhere. Like it is used in our studies only. It was a good method, but it was hard to recognize. So rules for using symbols. Yes, there are rules for some elements. The first letter that English name is used to represent the element, such as hydrogen, H. First letter, yes. Only first letter it's used there. Carbon, C, boron, B, oxygen, O, many more like that. Then for some elements, when the first letter matches, there are two elements, boron and beryllium. You all know it from our video of periodic table. If you have not seen it yet, just go, the link is in the description. Also see our playlist too, okay? I will talk about it in a later part. So as I said you, like there were these two, boron and beryllium. This is just an example. There are many like that. So their B is the same. So in boron we use B, while in beryllium we use with the second letter. It's Be, and thus beryllium goes to Be, like that. Remember that. Also there is bromine. It also starts with B. Then it's called Br, bromine. Also, then what happens is if something are there, such as the E and E both are same, Then what we do? We go to the next letter, that's third letter. And that continues in the whole periodic table. So now you can see that when the first letter is same, we use two or more elements, we use the second one, and if the second is same too, we use the third one, and so on alphabets. The next thing is, just an atom represents a symbol, a molecule is represented by a chemical formula. Yes, we will talk about it in a later part, but a molecule is represented by a chemical formula, and an atom, a single atom of hydrogen, is represented by element symbol. Okay. So now we have seen that just some atoms are named by scientists. Yes, some atoms are named after scientists and laboratories. Whoa. Some atoms are named after countries. Is it crazy? Yes, it is. Also, there are some atoms named after planet. Yeah? Well, now we are back, so we will see periodic table. What is this? You all wonder, right? So the classification of all elements we can find here, we can find every element. This is the classification of all elements, whether they are of any type, non-metal, metal, anything. You will find chemical symbol representations. We will see it in the next series. We will give you tricks to learn it too. Just see in the screen. You can easily see it, right? Okay, so you are right there. Next comes is radicals or ion. What are these? Why this many topics? No worries, radicals or ion are no new things. An atom or a group of atoms can lose or gain electrons. So there are two things. I will explain you in a very good way next. Okay, so let us see. Valency of an ion is defined as the unit of positive charge and negative charge. Radicals formed by the loss of electrons are called basic radicals or cations, and radicals formed by the gaining an atom are called anions. These are also called acidic radicals. Depending on the number of V's, ion V's is the number of ions that it gains or that it loses, or valency 2. We describe the name as monovalent, bivalent and trivalent. Now what is this all? Wait. Take two containers, okay? Here is one container, here is two containers. It has 99 solid red balls, while the 99 solid green balls, green balls, while the other one has 99 solid blue balls. Let me do a good representation. 99 there are, okay? Just I am marking it out like this, okay? Understood that? Yes, I think so, you might have. Then blue balls are here everywhere, okay? Also, it has only one ball. So, consider this as two atoms, okay? As two atoms, consider it as that. So, what happens is, it needs a green ball to complete the 100, and it needs a blue ball to complete 100. So they exchange their molecules, they exchange their balls. The blue ball goes this side and the blue ball goes this side. So now both have 100 and 100 same type of balls, okay? 100 and 100 same type of balls, and thus they completed their series. So what happened is, both lose their atoms while they gain their atoms. The green one lost one atom. Consider a ball as an atom. So the green one lost a blue atom. Thus, it lost an atom and it gained one. Like that happens in molecules, but in atoms, the main thing is either it loses or it gains or it collages. Yes, either it loses or it gains. Only one thing can happen. One atom is there, both persons use it properly and they join one thing. Our hydrocarbons are made like that only. Now let us see the thing. Equations. Here are some important equations. You can see it properly, okay? Here are they. So, when an anion, how an anion becomes? Let us see it. When a chlorine atom, just as an example, you can choose many other anions too, gains one atom from other elements, gains a chlorine atom, it becomes an anion or chlorine minus. Why minus? It is gaining, it should be plus. No, it is minus. Why it's minus? If you want to know this, watch the video till the end. By the way, if you want to know, let's say it now only. Minus is because it needs more power to control its electrons. It first had less than, it had more power to control the electrons, and it had less electrons. So when a molecule, when an atom comes, it becomes proper big, a proper structure, and thus the power of the neutrons and protons to hold the electrons becomes stable, and no more electrons are moving like that. Okay, and thus only it is minus, as first it had some electrons less. Same in cations, it is plus as there are more electrons first. Before losing the electrons, there are more electrons. So cation, when sodium or Na loses an electron, it becomes Na plus, and thus becomes a cation or sodium ion, we say it basically. Here is a table. Wait, let me show it to you first. So here is a table. It says all the thing: voltage, ionic radius of different ions. You can see it properly afterwards. Quote. You all might have heard this quote: by allowing the positive ions to pass through an electric field and thus giving them certain velocity, it is possible to distinguish them from the neutral ones. What does it mean? If you are a positive person, or if you are any kind of person and you are charged your brush properly, not that brush, but your brush from your skills, and your skills improve, you can be distinguished from the person who have not yet brushed, now, but who have not yet have skill, who have not skilled yet. So you should always do that thing. You should always brush yourself. Let us see next. No, not now. How to find chemical formula? You can see it how to find it. Let me show it to you too. So what do you do while finding a chemical formula is so simple. How to find a formula of a compound? How to find just that title. Step 1: take the elements and write their names. Write in such a way that the electropositive ion and the electronegative ion is in a proper order. So the positive ion is to the left, my left is this one, and the negative ion is to the right, okay? And also their valency below them. So if you written in the top like this, you can see here, their valency should be below here. Now what you do is finally crisscross the valencies. If it's like this, just crisscross this, just draw line like this, the valency of this belongs to that element and the valency of this belongs to that element, and add them all together. After this slide, here got an example I'll show you. When you add them all, it becomes the element 1 plus the valency of the second element, element 2 plus the valency of the third element, first element. I'm really sorry. Next, here is an example, okay? No worry. CaCO, calcium plus oxygen, when we mix it together, there is a certain difference by mixing it regularly, okay? What is the difference? It's so simple. Valency of both is 2. So when there are which can be cut out, or you can find a HCF between the most highest common, you find it. Here we found it 1. So we keep it down, both the sides, we keep it 1, 1. When we crisscross it, CaO is the final formula. As 1 goes here, and we do not represent 1. So you have the element here. Also an example can be CaO. Like other example can be AlO. Al valency is 3, you all know that. O is 2. So crisscrossing the valency, we get Al2, 2 below, and O3. That is another example. I said I will show you example. Al3O2. Al2O3 is the example of aluminium oxide. It's also called as aluminium oxide. Let me write it down. Al2 2O3 is the formula when formed from A, L and O. These both are separate. We get the thing as 3 and 2, and thus they crisscross to make like this A, L, O. We write the balance C, 3, 2. They crisscross and finally form A, L, 2, O, 3. Okay, now you have understood it. I know very well. Fun facts. There are some facts of anything, right? This was the last topic, so these are the facts. Valency of covalent compounds is neither electronegative nor electropositive. Not understood? Covalent compounds are the bonds between two atoms, the bonds between two molecules where one atom is used together. There is one chlorine. This is also sodium. And then when they meet and fuse, there is one atom of chlorine, which is more. As I said, it has more atoms. Sodium has more atoms. So that sodium atom is used here, and both use that atom. So sodium also uses that atom, chlorine also uses that atom, and that is called covalent bond. And thus, the covalent bond is not electronegative nor electropositive. It is none. Amazing, right? Let's see next. Now, there are 126 elements in the periodic table. First there are 118. You might ignore me right now too. I also said in that video, but no. There are 126. The last one is unbihexium. Yes, unbihexium. And now we will study periodic table. So from next video, you will study periodic table as I said. Next comes summary. I said I will say you the summary. So here it's summary. So here you saw that the symbols are a good way to represent elements. Yes, they are. Then you saw about ions. What are ions? Yes. And afterwards you saw some of the different type of ions such as radicals, basic radicals and acidic radicals. You saw that. And then you saw is how to write chemical formula. Yes. Next comes is thank you all. This was presentation by Schoolwork Gets team. Thank you all. Here are some symbols. Oh, good icons. Thank you. If you liked our video, please drop a like, subscribe to our channel if you have not yet, because stay tuned for the next update. And if you subscribe, you will be already stay tuned. Credits goes to myfreeslides.com and myfreeslides. That was it for this video. Meet you guys in the next video. Till that time, bye-bye. Like, share, and subscribe to Schoolwork Gaps. After this, I will short clip how you can mail us. You can the about section. If you have any doubts, mail us. Just click on that. You will directly reach Gmail, and from there you can mail us. If you have any doubts, just mail us at suppschoollwolgaps5@gmail.com. If you don't understand, I said after this I will play a clip. Just see it properly. Also, just go to